Okay, so this is our last video, you guys. This is solution, equilibrium, and precipitates. So with this one, what you're going to do is you're given this solubility product constants. And what this is known KSP values for certain compounds. Okay, so here you're actually given the KSP, you don't have to find it. But what we're going to do is these are known values. What we're going to do is we're experimentally going to find them, and we're going to call our KSP that we find is Q. Now if we compare this Q to the known, we can see if we're going to get a precipitate or not. Okay, so the Q is what we have. The KSP is what we need for saturation. This is the last line. Okay, so we compare what we find to what we know. And if our Q value is less than our KSP, so that means then there will be no precipitate. If they're equal, there's no precipitate. And finally though, if we find the Q that we have is greater than the KSP, then we get a precipitate. Okay, a solid will form. So to do that, what we need to do is we need to decide if there's going to be any possible precipitates. The easiest way to do that is to see if in the question you're given a KSP for a certain compound. If that's the case, then that's the precipitate we're going to be looking for. If not, you're going to have to see what the products are going to be and compare that in here with the solubility of common ion chart, okay, to see if you get a precipitate. Then you're going to need to do the dilutions formula. Okay, that's from 2.3, and that'll tell you if you're going to get your concentrations of both substances. Okay, then once you find those concentrations from the dilution formula, you're going to take those and use them to find the KS or find the Q value, and that Q value is what we'll compare to our KSP. Okay, so in the first question here, we're mixing potassium chromate and lead nitrate, and we want to see if lead chromate will form a precipitate. So that's what we're going to compare. So we're looking for the KSP of lead chromate. So we know that's what we're looking for. Okay, that's our precipitate. All right, so lead chromate is, there's a sec, I got it written all down here. So lead chromate is, ignore that, PbCrO3, that's a solid, and we're going to double check that when it displaces into lead 2+, which is a solid, and with chromate. Which is also solid. Okay, so we write out our thing. We notice all our coefficients are 1 to 1 to 1, so that means everything's 1 to 1. Now what we have to do is we'll set up our Q or our KSP. Our Q value here is just going to be our KSP that we're looking for. So it's going to be concentration of lead times the concentration of CrO3. Oh. Okay. So, first thing we're going to do is we're going to find the concentration of chromium. We're going to use now, up here we're given this about potassium chromate. Okay. We have a volume and we have a concentration. So we're going to use this formula here again. The initial molarity and the initial volume is going to equal that to the final molarity and the final volume. So our initial volume, our initial molarity was 0.002. Our initial volume, remember volume has to be in liters. Here it's a milliliter, so it's going to be, alright, now the molarity at the end we don't know. Now the volume at the end. This is dilution, okay? We started with 25 milliliters. We poured it in with 75 milliliters. 25 plus 75 is 100 milliliters. 100 milliliters is 0.1 liters. Okay? So now we just move that around, we multiply these two together, divide by 0.01. That's going to leave me with 0.0005 molarity for my concentration of CrO3. Okay, so there is my concentration of CrO3. Oh, sorry, that's Cr. Yeah. Okay. Okay, so there's my concentration. Okay. Now I need to do the same thing, but I need to do it for lead. So I'm going to set up the same thing as before. So MiVi equals MfVF. So my initial molarity for the lead was 0.00025. The volume was 0.07 liters. My final molarity, I don't know. My final volume, remember, was 100 milliliters. Like so. If I solve this all out, I'm going to get okay, so there's my concentration of lead. Now all I did is I just multiply these two and divide by this to get MF by itself. And that should be 10 to the negative 5. Okay. So now I'm going to look at my Q value. Remember, I have Q from up here. So I'm going to solve that over on this side now. So my Q is just the two concentrations multiplied together. So it's going to be 0.0005 times times 10 to the negative 5, okay? Work that out. I find my Q value is 4.69 times 10 to the negative 7. I found that when I compare that to the KSP that I was given, remember my KSP was given here at the beginning, it's 1.8 times 10 to the negative 14. So my Q value, ooh, that was a terrible circle. My Q value is actually bigger than my KSP value. So when that happens, if I look here again, remember, if Q is greater than KSP, a precipitate will form. So yes, therefore, yes, precipitate will form. Okay, so yeah, that's a pretty involved question, and I still have to do a harder one yet. I'm going to stop the video, load this up before my phone turns off, and then we'll do the next one. So go over it, make sure you understand it. If not, come see me anytime, and we'll talk about it.